Okay, so we're going to carry on with this idea of differentiation. Now, just a reminder, what's differentiation? Perfect. So you've got rate of change, gradient. Good. And it's also to do with tangents, right? So there's a gradient of tangents. Because the idea of differentiation, it's a way of finding gradients of things which are no longer straight lines. Yeah, we know how to find the gradient of straight lines, just rise over run. Differentiation plays on exactly the same idea, it's finding the gradient of curves. Okay? So, let's imagine I had something that looks like this. Okay, let's imagine I had something that looks like this. In fact, do you know what? I'm going to change this to a plus. Could you sketch that for me?
It's a 5 and a 6, 5 and 1.
Mm-hmm. So,
The intercepts are 5 and 1.
Which intercepts?
The x.
Good. Okay, so we find the x-intercepts. Remember, how do we find the x-intercepts? What do we set to be 0?
Y.
Perfect. So we set y to be 0, so if we get x squared plus 6x plus 5 equals 0. We go for the factorising, doesn't look too bad. So yeah, Ahmed, what do you say?
X plus 1 times x plus 5.
Good, excellent. We all happy with how we get there? Yeah? Okay, we're just literally looking for two numbers that multiply together to make 5 and which add together to make it 6. Okay? 5 and 1 satisfy that. Okay? Where do we go from here?
So we know that the x-intercepts are 5 and 1. So we sketch.
Do we know the x-intercepts are 5 and 1?
Oh, negative 5 and 1.
Good, because we're multiplying these two things together, they make 0, which means that's got to be 0, therefore x has got to be negative 1 to make that 0, or that's got to be 0, which means x is going to be negative 5. Yeah, good. Okay, what about the y-intercepts?
X equals 0.
Perfect, so we set x to be 0. So if we set x to be 0, we get y equals 0 squared
5.
plus 6 times 0 plus 5. Yeah, you're absolutely right, you can just read it off from that last number there as well, plus c. Okay, so y must be equal to 5. Okay. Are we all happy with that? That should just be revision. Yeah, all happy with that? How would we sketch this thing then? How would we sketch this thing?
Easy.
Okay,
So we start with the 2 lines. Little lines.
good, so these are our axes.
The y-intercept is 5, so we go to 5 and we make a cross.
So we know our x-intercepts, so one's going to be at negative 1, one's going to be negative 5. We know the shape of this quadratic, don't we? It's either a happy face or a sad face.
It's a happy face because the x squared is plus.
Perfect. The coefficient in front of the x squared, the number in front of the x squared is positive. It's positive 1. Okay, so it's a happy face. Okay, so let's go for this. So it's going to look something like this. Okay, then we just go ahead and we say that point there is going to be negative 5, that point here is going to be negative 1, and that point up there has got to be 5. Okay, you happy with that? Okay. Now I haven't asked you in this case, but I haven't asked you to find this point here. Okay, what's that point called again?
Vertex.
The vertex. Good. Okay. It's literally, another word for it is, anybody? Another word for the vertex? One of the words?
Turning point.
Turning point. Good. Okay. Now, are you happy to how we can calculate that because it's a quadratic? Okay, so how would we go ahead and calculate the vertex? I'm not asking you to do it, just tell me how you would do it.
Isn't it like when we take half of 6 and then we square and then it's a whole calculation?
Exactly, so it's completing the square, right? You
Yeah.
can complete the square on it and then use transformations of graphs. Okay. I'm not gonna get you to do it that way
There's a faster way.
because there is, well, not necessarily a faster way, but there's a different way that will apply to other graphs like cubics and quartics and things like that. Okay. Because another word for a vertex or a turning point is a stationary point. Okay, it's a stationary point. Now, let's play on this idea. What does stationary mean?
Not moving.
Yeah, not moving, not changing. Okay, not changing, not moving. That's what stationary means. Okay, so a stationary point, this point here, is a stationary point because it's not changing. What isn't changing? Think about it in terms of differentiation. Like this is a theme. It's under differentiation, so we must be dealing with the rate of change, or the gradient, or the tangent. So what isn't changing about this point here?
The y. It's in the middle of the x-steps. Y.
Think about it in terms of tangents. Think about it in terms of tangents. Okay? If I was going to look at the tangent at this point here, are you happy it's, so my tangent is my pen, okay? Would you be happy it's really steep and downwards? Yeah? So I could say the gradient would be really negative, really big and negative, so really big negative. If I move over here, would you be happy it's still negative, but it's less so, okay? So it's slightly less negative. So I'm kind of trying to show this through the size of my negative. So really big negative, slightly smaller negative. Are you happy as I get closer to this point, it's still negative, but perhaps less so. Yeah, it's less steep. Okay, so it's less negative again. Are you happy with that idea? So as you move closer to the stationary point, it's getting less negative. Less negative. Okay? But then as I move to the right, okay, here isn't negative anymore.
Positive.
It's positive. Okay? It's not very positive, but it is positive. Okay? If I move to say this point here, are you happy it's positive still, but slightly more positive? And you're happy by the time I get over this point here, it's much more positive. Okay? So have a look. Everywhere to the left of this stationary point, imagine this is a roller coaster ride, okay? You'd be going downwards. Okay? In other words, your gradient would be negative. Okay? As I move on the right, I'm going upwards now, going uphill. So my gradient is now positive. So what must the gradient be at this point here?
0.
It must be 0. Okay? I can literally draw that in as a straight line, a straight horizontal line. So at this point here, the gradient is 0. In other words, because the gradient talks about the rate of change, the rate of change is 0, which means it's not changing. The gradient is not changing at that point there, it's just a flat line. Does that make sense to everyone? Yeah? So the reason why we call this a stationary point, another name for this point, is because it literally isn't changing. The gradient is 0. Okay? Can anybody remember what's the notation that we give to gradients for differentiation? D.
Oh, dy by dx.
Good. Okay. So we're literally saying that dy by dx is equal to 0. Okay? dy by dx is equal to 0. So let's have a think. I know that this is my curve. Y equals x squared plus 6x plus 5. Okay? I want to find this point using differentiation. So literally, these ideas sums down, or comes out as, or sums up as, I should literally differentiate it and set it equal to 0, solve that equation, and I should find my stationary point. Does that make sense?
It does. Doesn't it?
It should make sense. So this point here, so let me just reiterate, this point here is called a stationary point. The reason why it's a stationary point is because at that point, the gradient is 0. So what this literally means is that when I differentiate my function, I should set it equal to 0 and find which x coordinate it should be. Okay, have you done it? Perfect. Okay. Let's do it together though. Let's do it together. Okay. So here's my function, y equals x squared plus 6x plus 5. Okay. To find my stationary point, what I should literally do is differentiate it. So if I differentiate it, what do I get?
2x plus 6.
2x plus 6. All happy with that? Yeah? And once I differentiate it, in order to find my stationary point, remember this is a gradient function. It gives me the gradient at any point I like.
So 3.
But I want it where the gradient is equal to 0. So here's my gradient, 2x plus 6. If I set it equal to 0, then I should find my stationary point. So I would write something along here, which says a stationary point, SP if you want, occurs when dy by dx equals 0. Okay? Show me that you know what you're doing. Okay? So a stationary point occurs when the gradient is equal to 0. So here's my gradient. If I set it equal to 0 and solve this equation, I should find my stationary point. Okay? So if I solve this, what do I get? Vatican? -3. Okay. So I found my x-coordinate. Now I just need to find my y-coordinate, but that is easy. How do I find my y-coordinate?
Place it back into the y.
Absolutely. To find my corresponding y-coordinate from an x, I use this equation here. It literally says, you give me an x-coordinate, and I'll tell you what the y-coordinate should be. Okay? So I get y equals -3 squared plus 6 times -3 plus 5. Okay, well -3 squared is 9 plus 6 times -3.
-32.
Be careful.
Oh, for activating.
Yeah, good. 9 take away 18 is
-4.
negative. Perfect. -4. Yeah? So in other words, my stationary point is going to be -3, that's my x-coordinate, and -4, that is my y-coordinate.